In this final section, I'm going to discuss reinforcement placement and detailing. This is a very important part of reinforced concrete design that often will govern the spacing of the bars. And you'll notice on the standard details, we have 3 different sizes of reinforcement, steel reinforcement in the anchor. A01, or number 6 bars, compose the longitudinal straight bars. These provide the main flexural reinforcement for the beam, as well as temperature and shrinkage on the long axis. A02, or number 5 bars, are used as erection hooks for cable hoisting. These are only placed in the adjustable side and will be analyzed separately in the construction safety checks. A03, or number 4 bars, compose the stirrups. They serve a purpose of holding in place the longitudinal reinforcement as well as providing shear reinforcement in the beam. Chapter 9, sections 9.6 and 9.7 provide information on reinforcement limits and detailing for beams. And I have circled this here just to show that we're in a beam condition, so we're going to be referring to our ties or our shear reinforcement as stirrups instead of as ties, which we would refer to as if they were in a column. So we can make our way through these sections numerically, pulling out what is relevant for rebar spacing. And do note that this information goes into far more depth than what I've pulled out here, but I'm just going over the big ticket items that could govern our design. So we'll start with minimum flexural reinforcement, AS, as specified in section 9.6.1. First, and obviously, AS is required everywhere where required by analysis. So this is just a statement that AS should be adequate in strength to resist flexural loading. And then next we have section 9.1.6.2, which stipulates that AS should be the greater of the following: 3 squared F prime C over Fy BWD, or 200 over Fy BWD, which is equation A is related to the strength of the concrete relative to the steel to have a balanced section, while equation B is based on temperature and shrinkage requirements. Section 9.6.1.3 states that these equations can be ignored if AS is greater than 1.33 AS required by analysis at the section. The next major applicable section is our minimum shear reinforcement, AV, in section 9.6.3. You may remember from the sectional strength design lectures, shear reinforcement is required wherever VU is greater than 0.5 VVC per section 9.6.3.1. Next, we'll find our minimum values from table 9.6.3.3 for non-pre-stressed reinforcement with no significant torsion. So that's the greater of these two values, 0.75 squared F prime C BW over Fy or 50 BW over Fy.